Hello, Intro to Proofs. This is section 3.4, and we're doing progress check 322. So we're going to try to complete the following proof. So proposition says that for all real numbers, A and B, A and B, if AB equals 0, then A equals 0 or B equals 0. Proof. Okay. So we let A and B real numbers. Yeah. Let A and B be real numbers. A and B be real numbers, and assume that AB equals 0. We will prove that two cases, A equals 0, I'll write it the same way they do. We will prove that A equals 0 or B equals 0 by considering two cases. Okay. Colon 1 is that A equals 0, or and 2 that B A equals not equals 0. So now, in the case where A equals 0, this is our simplest case. So we're trying to prove that A equals 0 or B equals 0. If A equals 0, then A equals 0 or B equals 0 is true. Then our conclusion is true. Really, it's logically true, right? We're using a property of logic. And the property of logic we're using is that if I have a true statement or something else that's equivalent to a true statement. So that's the domination law. So our conclusion is true by the logical, there's only one L in logical, let's make it up that L. Logical domination law. If that was the easy one, I probably didn't even need to say that. Like, in the case where A equals 0, our conclusion is true. I probably could have just said that. Now, in the case when A is not equal to 0, so what do we know? We know that A times B equals 0. So then I can dividing our by we consider, so I want to consider that AB equals 0 and then divide by A. So that's took me a while to kind of formulate my thoughts there. So in the case when A equals 0, then dividing both sides of AB equals 0 by A gives us that B equals 0. Right? And we can divide by A because it's not equal to 0. Maybe I should have said that. Maybe it's okay. It's kind of one of those things where you gotta know your reader. So my reader, I'm intending them to kind of know algebra, that I'm assuming like high school level of algebra knowledge of my reader, which is very good, very fine. So because a is not equal to 0, I can divide by it. Whereas if a equals 0, I can't divide by it. Okay. Thus conclusion is proven. So maybe I'll just change this period into a comma, which gives us that a equals 0 or b equals 0. Right, so if this is true, then that by the logical domination law. Since both cases are proven, the conclusion is true. It's a good way to wrap it up. Let's use, let's see, a good example of wrapping up two cases would be, because we've proven both conditional statements, because we've proven both cases, the conclusion holds. That's kind of a slow, kind of a lazy way to say it, is to say the conclusion holds. I could just restate my conclusion as well. That'd also be great. It'd be a little bit better than what I'm saying, but also say the conclusion holds. Conclusion, especially because I've already said my conclusion, what I wanted to prove here. So that helps that I already said what I wanted to prove. That helps me to just say, be lazy now, because I've already said it. Conclusion holds. All right, that ends preview progress check 322.